Everyone's attention. Okay, good afternoon, all of you, ma. So, in this class, we are going to learn about the probability theory. So, in the previous class, we learned about the confusion matrix. I hope you all remember the confusion matrix. So, it is an evaluation matrix for evaluating your classification problems. The next one is probability theory. What is actually, you all know the probability, right? So probability is mostly a uncertain one, in that we want to find the possible occurrence of a particular event. So this probability is important concept in statistical analysis. Even though we say it is an important concept or mathematical method in statistical analysis, we can say both of them are interconnected. Who are they? Probability and statistics are interconnected branches of mathematics. So the probability make use of statistics and statistics make use of probability. So, as I told you, what is probability? It is likely how possibly a particular event may occur. So, if I have dice which have 6 values in it, right? 1, 2, up to 6. So, when I throw a dice to get 3 out of it, what is the possibility? Is 1 by 6. So, our event to occur is 3. I want 3 to get in a dice when I throw it. And the what is the probability is 1 divided by 6. So out of 6 individual events, what is the probability of getting the 3 number event? So that is what the probability. It's a measure of how likely an event will be occurring. Now what is our event? Getting 3 is an event. And so out of 6 possible things, getting 3 as an event is 1 divided by 6. So that is what a probability, how likely an event will occur. So it is the ratio of desired outcome to the total outcome. What is the total outcome? 6. That is 1, 2, getting 1, getting 2, getting 3. That is all. So totally 6 outcomes can be there, possible outcomes. Out of which, what is our desired outcome? Getting 3. So that is 1 divided by 6. So it's a ratio of desired outcome is 3, that is coming 1 time out of 6 times. So getting 3 is our desired outcome, that is 1 divided by the total possibility is 6, which means 1 can be coming, 2 can be coming, 3 can be coming, 4 can be coming, 5, 6. So out of this 6, getting 3 is a 1 time possibility, right? So it is 1 divided by 6. So one more important thing you have to remember here is when you get a probability, the possible outcome should always finally you have to get a sum of 1. Say for example, it should not be so always your probability should be either 0 or 1. Either you have to say either this will today it will rain or it will not rain. So that is how your answer should be. So always the sum of our probability should be 1. It will not be like, so that is what said here. So the sum of the probability should be 1. For example, when I throw a dice, it has the values of 1, 2, 3, 4, 5, 6. So each are individual events. So what is the probability of getting 1 in the dice? 1 divided by 6. And what is the probability of getting 2? 1 divided by 6. So when I throw, there may be 6 possibilities, out of which getting 2 will be one of that particular event. Similarly, getting 3, 1 of 6. So desired is getting 2, that will be 1 time coming, and out of the 6 events. So then 4 is 1 by 6, then 5 is 1 by 6, and then 6 is 1 by 6. So when you sum all this, see, when you sum all this, what will you get? 6 divided by 6, and you will get the answer as 1. So that is what it said as probability of all outcome. So this is the outcome of probability of outcome of getting 1. So this is the probability of getting outcome of 2. So this is a probability of getting an outcome of 3. So when you sum all this outcome, you should get finally as 1. So that is what's said here. The probability of all outcomes always has a sum up to 1. So this is all the possible outcomes, all outcomes, right? Getting 1 is 1 by 6, getting 2 is 1 by 6. The probability will always have sum of 1 and it cannot be decimal values. So it cannot, the probability value will not be like this 0.52 or 0.78. It will not be coming as a decimal value like this. It should either say 1 or it says 0. It cannot be a value in between. So the sum of all the possible outcomes should be 1. So this is about the probability theory. So what I explained is denoted here. So it is a dice, right? In a dice, we have all this combination. So 6 combination is there. Getting 1, getting 2, getting 3, getting 4, getting 5, getting 6. So while you roll a dice or throw a die, we will be getting 6 possible outcome. That is what 1 can be there. Sometimes 2 can be there. So the probability is out of 6, it will be coming for 1 time. So that is what. So now each phase have the probability of getting 1 divided by 6. So when you sum all this, as I told you in the previous thing, when you sum, you will get 1. So in the probability theory, we have some of the important terminologies, are the words, are the terms which used in probability theories. First thing is random experiment. So 3 things are here. One is random experiments. So the terminologies we will be using mostly here is one is this one, random experiment. Another one is sample space. Another one is event. So let us see one by one. What is random experiment? Random experiment, it is a experiment or it can be any process in which we'll be getting an outcome that cannot be predicted with certainty randomly. For example, when I throw a dice, I will not be certain that this time I will get only 5. I cannot be certain about my outcome. So that is called random experiment. So I'm rolling out a dice. Will I be certainly saying that no, when I roll this time I'll get only 6? I cannot certainly say. I cannot be predicting with the certainty, right? So that is what called as random experiment. An experiment, what is an experiment? Rolling a dice is an experiment or a process. And when I roll that dice, that is an experiment or a process in which I cannot certainly say I will get this. So that is called as random experiment. So we can use this probability to predict the outcome with some sort of so we can use so this is what random experiment is. What is probability? We can predict some amount of certainty, so we can use probability to predict the outcome with some sort of certainty. What is the certainty? I told, when I roll a dice, there is totally 6 things. What is it? Totally 6 outcomes, out of which the possible certainty of getting 3 is 1. So likewise, I can give some sort of certainty. That is what called as probability. So random experiment means I have a experiment, or rolling a dice is an experiment where I cannot give any certainty. Probabilities, I'm going to give some certainty. What I'm saying, when I throw, I have 6 outcomes, out of which the some sort of certainty is getting it by 1. So that is what, if you consider the rolling dice, finding getting 2 is the random experiment. Okay, and so then what is an what is a sample space? So next one is random experiment. We know there is no certainty. Probability also I told. What is sample space? So sample space means it's the entire set of outcome of. So in random experiments means, what are they? To get 1, I get 1 by 6. To get 2, I'll get 1 by 6. So out of this, I will not, to get 3, that is 1 by. So this is all, I will not be certain about it. So all possible things, I'll say random. That is a random experiment. So in this entire possible set of outcome of random experiment, an event is one or more occurrence of an experiment. So out of which this all possible times, for example, we want to find this is the total random experiment. Out of it, what is the sample space in your entire possibility? That is 1, 2, 3, 4, 5, 6. These are all different possibilities, and out of those, if you want to find the probability of getting 2, no, that is what called a sample space. Okay, so which will be represented by 1 divided by 6. So all possible outcome will be represented as sample space. So 1 to 6 are all possible outcomes. So So getting 1, for example, if I want to write, sample space of getting 1 is 1 by 6. The sample space of getting 2 is 1 by 6. So I am not certain about my outcome, that is random experiment. Out of it, I'll get a certain possibility to get a particular outcome. That is called as sample space. And what is an event? Getting 2 out of this is an event. Getting 5 out of this sample space is an event. So event is one or more outcome of an experiment in which the event is to get 2. One particular event to be occur, that is what called as event. So the probability of getting event 2 in this dice, six faces of dice means 1 by 6. Okay, so these are some of the terminologies we will be using when we roll a dice. So I'll repeat, random experiment is all possible outcomes that can be, so we'll get complete when I do some process, rolling a dice, I will not be able to get any certainty, that is random experiment. What is sample space? So when I have this rolling of a dice, I have different phases of 1 to 6 in which all possible outcome is sample space. And what is an event? In this, getting 2 is an event. Getting 6 out of the 6 outcome is an event. Now the next one is, we have 2 types of event. One is disjoint and one is non-disjoint events. So what is disjoint event means? The event that do not have any common outcome. For example, so when I hope you all be knowing cards, right? So when I draw a card from that deck, it could be either king or queen. So it cannot be both king and queen. So this is called disjoint event. So I hope you got it. So both things will not happen. That is disjoint event. What is non-disjoint? 2 things may occur in a common things. For example, I can score 100 in maths as well as 100 in science. So 2 events, 100 is occurring as a common thing. So getting a king and queen, there is no common. Either it should be king or it should be queen. But that is what disjoint event. What is non-disjoint means? I have a common occurrence between them. So this is a math subject and this is a science subject. So out of which both I can get 100. So event, non-disjoint event that has some common occurrence. So when I have 2 events, I can have a common occurrence of getting 100 marks. So this is what non-disjoint event. I hope you got it. Disjoint event means something will not occur in common. Do not have any common occurrence. It's called disjoint event. When we have a common occurrence, when we during some event, that is called as non-disjoint event. Okay, I have explained it. Okay, the next one is probability types. So there are 3 types of probability. One is marginal probability, joint probability, and conditional probability. I encourage every one of you to read your textbooks when you textbook. Okay, when you come to tomorrow's class, I will ask question from this probability. So in book they have given an example. You just go through it. So now, as of now, to make you to understand this probability type, I'll give another example. So 3 types of probability are marginal, joint, and conditional probability. So the probability of an event occurring unconditional or on any other event is marginal probability. So the first one is marginal probability, which means it will not be depending on anything else. Okay, separate thing. So 2 events, as I told, getting a king is one event, getting a queen is another event. So there is no if it is, there is no condition between occurrence of this 2 event is a marginal event. So the probability of event occurring unconditional on other event, it is not depending on other event, then it is a unconditional probability, also called as marginal probability. Let's say, take a scenario. So here there is a group of 10 people. Out of this 10 people, 6 people are what? 6 people are women and 5 people are men. Okay, so 5 are men. You can count it. That is 1. This is 1, and then 2, 3, sorry, 4 only, right? Out of 10. So 4. So 4 men are there and remaining all are women. So this is my complete what space? Complete sample space. So out of which they are so 10 peoples are there, 6 is women and 4 is men, and then they all like pizza. But when they have pizza, in that they have a separation. See, 1, 2, 3. 3, no, no, 1, 2, 3. Yeah. 3 people doesn't like this pepperoni, which means something that's spread on that pizza, right? So out of this 10 people, 3 of them doesn't like this pepperoni sprayed on that pizza. So out of this 3, you can see 2 is men and 1 is a women. Okay. So this is how this is our sample space. So now let us, from this, what is that experiment, we will learn what is the type of event, that is marginal, join, and conditional. So now you can see here what is marginal, the probability of event occurring unconditional to another. So here I can say how many, if I, from this 10 people, when I pick women or men, how many probability I'll get? So 60, as I told you, 6 are women and 4 are men. So what is the probability of getting women? 6 divided by 10. So 60 percentage. What is the probability of getting men? 4 divided by 10. So that is the individual event. So, and then what is the marginal probability of getting pepperoni preference? So I told you, out of 10, 7 likes pepperoni on the pizza, 3 only doesn't like pepperoni on the pizza. So what is the probability of that? 70 percentage is liking the like pepperoni on the pizza, and 30 percentage doesn't like pepperoni on the pizza. So this is what called as marginal probability, which means this is another event, this is another event which doesn't depend on each other. So that is what unconditional probability, a probability of an event. What is getting a men or women doesn't depend on preference on the pizza. So the probability of event occurring unconditional on other event is known as marginal probability or unconditional probability. I hope you got it. So getting a women or a men doesn't depend on the event, will they like pepperoni and pizza or not. So this is called as marginal probability or unconditional probability. Okay, what is the next thing is joint probability. What is joint probability? Means two events occurring at the same time is joint probability. For example, I want to now know how many people, like people, what is the condition I'm going to have is, the joining condition is the people should be women, and they should be liking pepperoni. So out of 6 women, how many likes pepperoni? See here, how many women are there? 1, 2, 3, 4, 5, 6. Out of this 6 women, so the condition is he should be the person should be women and they should like pepperoni. So out of this 10, this matching these two conditions, women and pepperoni, how much are there? 5, because 3 don't like pepperoni, out of which 1 is a women. So then we can understand, out of 10%, 5 satisfy this both condition, women and liking pepperoni. So what is the joint condition? That is 50 percentage. Out of 10 people, women and liking pepperoni. So I hope you can understand. Women is totally 6. Out of 6 women, only 5 likes pepperoni. So our condition is women plus liking pepperoni on the pizza. So satisfying this two condition, out of 10 sample is 5. So because 5 women likes 5 women and they like pepperoni, 1 woman doesn't like pepperoni. So what is the probability? 5 divided by 10, that is 50 percentage. Okay, so that is what joint probability. Both the conditions should be satisfied. Okay, what is the next one is conditional probability. What is conditional probability? Based on one event, something else should be happening. So that is depending event. Okay, so if the wind is blowing, then only there should be a rain. Some based on one event, if another event is occurring, then that should be called conditional probability. And mostly this probability is denoted by P of x comma y. So they are not depending on each other. This is probability of x and y. So two things are depending on each other. So this probability is depending on probability of B given A. So if the event A occur, then B will be occurring. So this is what conditional probability, which means here out of 6 women should be there, and if they are women, how many likes pepperoni? So the first condition is what, women, and if the when I randomly pick a friend, that is what always. So the condition is women. Women only we have to take. That is the condition. And in the women, how many likes pepperoni? 5. So that is 83%. So based on one condition, first condition is women. And in the women, how many likes pepperoni? 5 likes. So that is what conditional probability, that is denoted by P of A given B. So based on A event, we will be predicting the B event. So based on 6 women, how much like pepperoni is like the conditional probability. So that is denoted by P of A and B given probability of A. A occurs, and then based on that, both conditions are satisfying. So this is called as conditional probability. So these are the 3 types of probability. I hope you got it. So when there is no event, so probability of an event occurring unconditionally, without any condition, if some probability occur, it is marginal or unconditional probability. Joint probability means 2 conditions should occur together. Then it is joint probability. Conditional probability is based on one condition, another condition will occur means based on a condition. If another event is occurring means it is a conditional probability. So I hope you got about this. Okay, I hope you understood this. So in general, we can say like this. So marginal probability means what? Probability of individual random variables. Okay, individual. Okay, I have told this notation in this way. P of x or P of y. There is no connection between it. There are different individual random probability. And then joint probability means probability of 2 or more even occurring at the same time, P and y. And this is a conditional probability, one event conditionally occurring on other event. So x event will occur based on the y event. So it is a conditional probability. Okay, I hope you got it. So do you all understand this different types of probability